Hi everyone, my name is Brian Chu, and I'm going to go over a practical introduction to software QA. This lesson would be beneficial to anyone that is not too familiar with quality assurance, but they're looking to get into the field. Before we begin, I'd just like to go over my experiences in the field. I began software quality assurance and testing in around 2008 as a co-op student. During that time, I was testing the online banking system for a large Canadian bank. And since then, I worked on television receivers, gold inventory systems, and eventually environmental health and safety enterprise level software for about 6 to 7 years. From my experience, the specific type of software you're testing, it's not too important as long as you know the fundamentals for quality assurance and you know how to make a great product. That's quite transferable across various types of software in the industry. Unless you're doing something like highly specialized, such as like an automation engineer or like a security testing engineer. But this will just cover the basics of quality assurance and the fundamentals someone would need to know to get started. So what is software quality assurance and why do we need it? Basically, software quality assurance is the validation and verification that software is designed as intended. And how it's intended can come from various sources. It can come from technical documentation, business requirements documents, project manager or product owner, and often a discussion between team members and even common sense. For example, like if an image on a website, if it was displayed distorted, let's say the width was twice as much as it was supposed to be, a document might not go in the depth that describes that an image has to be displayed correctly. It's generally common sense, and generally you'd be able to log a defect without any reference. But it ultimately depends on how your team and department operate, as no two companies are exactly the same when it comes to how to log defects or like who to discuss with when logging defects. As for QA operations, I think it's supplementary to existing operations. For example, a development or something like a client-facing department. In that, if there's no like subject to test, such as software or design or even like processes, then there'd be no need for QA. But of course, there always is something in a business, such as ensuring that there's a good process, that code reviews are being completed correctly, that document designs are being assessed by the correct stakeholders. That's all part of QA as well. But typically, when someone thinks about QA, they're generally just thinking about the testing of the software, which is primarily what someone does when they're new into the field. But quality assurance should reach everything that has an influence on the outcome of the software, such as the analysis, design, and implementation in a systems development lifecycle. And because QA is often considered supplementary or secondary to other activities such as development or design, for someone new in the QA field, it might seem like that QA gets overlooked compared to those other departments. However, good management and leadership from the company will recognize the value that it brings to the end product. Typically, if a company is overlooking QA, they're probably not making a good product. And you should take that into consideration if you want to work for a company like that. So, why do we need quality and testing in software? The answer is pretty simple and straightforward, and it's the same for any complex product or item that would require QA and testing. A low quality product can and probably will lose a company money. It could be due to a poor user experience, such as an interface being unable to operate as intended, or a case where the software for a chemical factory processes data incorrectly, causing a catastrophic accident leading to bad press, or a defect in a video game causing a gamer to be unable to complete the game. Like these quality issues can be minor and cosmetic, but it can also destroy a business in the extreme case. On the other hand, quality assurance can also be used by a company as a competitive advantage. Some examples include Apple mobile application ecosystem having tight tolerances for applications they allow into the marketplace, or a web browser that runs smoothly without excessive amounts of resources used. Customers are happy to use these products over alternatives if they have positive experiences. And these positive experiences are often attributed to many cycles of testing and development. It's very rare for a developer to release something on its first cycle and have it go live without any defects or enhancements whatsoever. So hopefully after listening to this, I've piqued your interest in software quality assurance, and you may be asking yourself what skills, education, attributes I should have to begin a career in this field. From what I've seen education-wise, typically a degree in software development, IT, or engineering. I myself graduated with a degree in IT management. I've also seen people come from different backgrounds, such as accounting and graphics design. Although it's easiest to get interviews when you're studying development, IT, engineering, or mathematics. It can be argued that having a team of diverse QA analysts and testers, it may be good for the software as you get a lot of different viewpoints on how that software should behave. Sometimes if someone's very technical, they might miss out on something such as a spelling error or the layout of an interface. Generally, the more technical the position is, let's say a QA automation engineer or the security analyst, you would want someone with the experience in that field. But if you're dealing with, let's say, end users, you can be more flexible and diverse in the educational background. Also, an education may suit a specific type of software being tested. For example, if it's a financial software, you'd probably want someone in finance, or if it's a video game, you'd want a game designer. So it really depends on that situation and what your role is on that QA team. In terms of skills and attributes that a QA analyst should have, it's quite important that you're a problem solver and have analytical thinking skills. This comes in very handy when trying to reverse engineer defects. You may see a defect and you'll need to know what's causing that defect and try to translate it so the developer can find the code matching what you see on the output. The problem solving and analytical skills come in very handy when you're trying to reproduce, let's say, a sporadic bug where you get the result sometimes and other times you don't. It might be because of, like, let's say there's multiple people stressing the server at that time causing that. And if you can't think of why that's happening, eats up a lot of the time. So a good problem solver with good analytical thinking can be far more efficient and productive than one that is not a good problem solver. And that definitely matters as most of the time you're working on something with tight timelines and you want to find as many defects as possible as soon as possible so the developer has time to fix them. Another good skill to have is being a good communicator and collaborator, as you'll likely be working in a team of either other QA analysts or testers, or directly with developers and project managers. Often when working on projects, you'll have tight timelines for completion, and everyone on the team is stressed out. A good QA analyst can maintain being level-headed despite the stress and pressure involved. A poor QA analyst will probably skip tests and just mark them as passed, which is probably the most catastrophic thing they can do as it defeats the purpose of QA in the first place. And if you don't manage workloads well and you can't effectively communicate with your team, ultimately you may be doomed for disaster. Lastly, you want to make sure you're familiar with the technologies required to fulfill the role that you're applying for as a QA analyst. Let's say, for example, for web pages, you want to know HTML, JavaScript, If you're applying as an automation engineer, you want to know whatever automation tools they're using. It could be Selenium or Cucumber. And if you're doing database work, you'd probably want to have knowledge in SQL. Technically, it's pretty straightforward. So now that you have an idea of the education and skills required to be a good QA analyst, you might be wondering what activities you'll be doing as an entry-level QA or test analyst. And as mentioned previously, likely you'll be working in a team, and that team will likely consist of other QA analysts, probably a QA lead or a QA manager, or you might be in a smaller, let's say an agile team consisting of like a few developers and a project manager. I've been in teams with just me and a developer, so I would find bugs and directly talk to that developer to fix them. That's like a small project. But because, as I mentioned, QA is generally supplementary, you're always going to be working with someone. If you're working on a project from scratch, that's to say there's no development or let's say even analysis or design, you're likely going to be going to meetings with systems analysts, business analysts, just a bunch of different stakeholders within the project. And you'll be trying to get a feel of what the intended software or product is supposed to look like. You'll also be reading as much documentation as possible regarding the software because you may be creating test cases for that software, assuming someone hasn't already created it for you. In simple terms, a test case is a set of instructions that should be run under a specific environment or under specific conditions in order to confirm whether a requirement is met or not. Or in other words, a set of steps to verify that the actual behavior matches expected behavior. You may also need to maintain those test cases, so that's going into the documentation of the tests and updating them as business or system requirements get updated and that all documentation aligns. Next up, we have actually testing the software. Now for testing, there's various categories of testing. Some examples of how we categorize testing includes whether you're running the tests manually or through automation, whether you have access to back-end code or data, which is called white box testing, or if you're quite blind to the back-end infrastructure, which is black box testing. It can also be categorized to what phase that level of software is ready for. So you can test just a component of the software, or you can test once that component is integrated into the system. You can perform ad hoc or exploratory testing, which is just testing without a set of guidelines or test cases to try to find new issues that wouldn't normally be discovered if you're just running a set of tests. There are also functional and non-functional test cases. Functional being you're testing whether software performs specific function. Non-functional, you can kind of look at performance, compatibility testing, stress testing, and usability testing. And these categories are not mutually exclusive, so you can have a non-functional integrated automated test. Regardless of what kind of tests you're running, one thing is quite likely. You're going to be running those tests multiple times, at least once for each iteration of software. And if you're running manual tests, it may feel quite tedious. So being able to perform repetitive tasks is also an attribute of a tester. For example, you might find a sporadic defect and you will have to rerun the same tests over and over to narrow down how to reproduce that bug for the developer. Often in parallel with testing, there's also defect or bug logging, and that's when you find a variance between actual behavior and expected behavior. This may occur for a multitude of reasons. One being that a developer may have interpreted a requirement incorrectly. Another could be that the developer might have just mistyped some code or perform some logic in the code incorrectly, or sometimes the software may perform erratically under a certain set of conditions, such as if there's a lot of users hitting the software at the same time, or potentially during a date change, something might happen, or something condition based. Whatever the case may be for that defect, it's the QA analyst or the tester's job to log that defect. And when they log that defect, they want to be as clear and concise as possible, so it's easy for a developer or some project stakeholder to understand and reproduce. So working in a team, creating and maintaining test cases, testing the software, and logging the defects, that would probably cover about at least 70% of what a entry-level QA analyst or tester would perform. I hope by listening to this you have a better understanding of what QA is and testing is for software, how to begin a role in the QA industry, and the activities someone begins when they start in the QA industry. I'll likely go over the activities in more depth regarding the tester or QA analyst and teams and projects, more about the testing, more about defects, and more about quality assurance practices and procedures. If you have any questions about this introduction, please let me know and I'll try my best to answer them. Thanks.